It's really my pleasure to introduce Piotr Kupisz, who is Associate Director at Accenture Poland. And Piotr is involved in one of the most amazing mainframe migration projects. And well, he's going to tell us tons of things about it. Piotr, the floor is yours.
Hello, everybody. Thank you, Darius. I hope that everything is visible. Can you see my presentation? Okay, so hello everybody. Today I'm going to share with you the story of the platforming of a large mainframe system. Usually when you hear about replatforming, you encounter cases with hundreds of MIPS, or you encounter cases with thousands of MIPS, but you may be wondering whether it's possible to replatform a system with 10,000 MIPS or 20,000 MIPS or even more. And the answer is yes, it's absolutely possible, and this will be the story about it. So first, let me say a couple of words about our customer. This is a large universal bank in Central Europe, and this story is about replatforming of their core banking system. The core banking system is usually the heart of IT landscape for every bank. It is processing accounts, loans, millions of transactions every day, must be available 24 hours by 7, and must be available real time. Our customer has over 10 million customers, all segments, retail, small and medium enterprises, as well as one of the largest corporations in Central Europe. It processes over 20 million of current accounts together with their transactions, whether they are financial or non-financial ones. From the technical perspective, the system is over 20,000 MIPS, and the traffic that is generated by the customers, be it mobile, internet, or branch, is well over 3,000 CICS transactions per second at peak. Before we jump into the project, let's think for a while what a mainframe replatforming with Raincode is. So first, you take your COBOL code that you coded and you developed over the last 50 years with all the precious business logic that you have. You compile it with Raincode compiler into .NET executable files, and then you run it on Windows or Linux server. So it's as easy as that. Of course, mainframe application is not only about COBOL. It's also about maintaining running your batch processing, file sorting, monitoring, and scheduling. So you will need other Raincode and marketing tools for file sorting, monitoring, scheduling, and so on. In our case, we are using Raincode Raincode batch stack to interpret JCLs and to process them. We are using DMX for file sorting. We are using Kibana and Elasticsearch for monitoring, and also Automate Now for scheduling. Of course, you also need to think about target database. So in our case, this is DB2 PureScale for Linux, but you may use Microsoft SQL Server as well. Finally, you can enjoy your app on open platform, liberated from your old good mainframe. So much for mainframe replatforming. Now, why is it good to think about replatforming? You may say that there are other ways that you can change your app. This might be either rewriting the application, or this might be implementing a new system. Well, in general, usually these two ways are far more expensive and riskier for organizations and for the people that run the projects. In case of core banking system replacement, it means really huge funds, huge project, and the risk that in the end everything can fail. Half of core banking transformations usually fail, so the risk is really high. And this is the reason why it is better to do replatforming instead. And let's go through details. So first, replatforming is possible and can be performed in a safe way. Absolutely, this is a safe way to transform your system, and the risk that something fails can be really limited almost to zero. Second, with replatforming, we can build appealing business case. The platform cost cuts range from 30 to 80%. In general, the more MIPS you have, the better the business case can be delivered. Replatforming also lets you to retain your IP and lets you retain your current business logic. So if you are implementing a new system, usually you will not have the IP rights, and you will also face a new business logic, which is very often standard and not as complex as what you have built over 50 last years. And you will have to make decisions whether you want to customize heavily the new system or whether you abandon this business logic. Replatforming is also a significant transformation with no impact on business departments. What it means, if you implement a new system, your business people will be heavily distracted from business. They will have to analyze the system, identify gaps, they will have to document requirements, sign off them, then go through acceptance tests, and at the very, very end, decide whether what has been built is what they really wanted. When it comes to replatforming, it's far easier for them. They are almost not involved. Then they can concentrate on business. And in case of replatforming, they are actually passive investors looking forward to benefit from future positive cash flow. Replatforming brings no impact on business functionality development. So if you have a new system implementation, you cannot afford to have a moving target and to chase it. Instead, you rather limit development of the old system, and at some step you need to stop it. So that means that your business cannot develop. This is completely different while you are doing a replatforming project, because you can deliver business functionality with almost no limits during the project in parallel to it. Well, that's trivial. Replatforming is a response to labor market. It's difficult to find young people who want to work with mainframes. I would say it's almost impossible. So if you want to be attractive for young people, you have to do something with your system, and replatforming is one of the ways. It will be far easier for you to attract new people, young people, and make your system being maintained. Replatforming also allows you to enter new platform technologies like cloud or DevOps, and this will allow new possibilities and future cost savings. That's also trivial. New development tools and DevOps will allow agility and time to market. So that's something that is very important today. Last but not least, Raincoat offers native interoperability, which means that COBOL components will be able to call .NET ones. The .NET components will be able to call COBOL modules, and this will be without any middleware. So just think what it means to your team. You will be able to recruit new workforce who usually have pretty sound, pretty good .NET skills, and you will not have to start from scratch with learning with teaching what mainframe and COBOL is. And you will be also able to convert your current COBOL team into .NET world. They will be able to learn .NET, and you will retain their knowledge of business and of system functionality. One of key assumptions is the coexistence. The coexistence actually means that the new and the legacy can work together in a consistent way. So before you start the project, you have transactions, batches, and database, everything on mainframe. Under the coexistence mode, you can gradually migrate your transactions from mainframe to the open world. You can do it week by week, move groups of transactions from one environment to another one. And these transactions will be processed these transactions that you will move will be processed in a Windows environment while still operating on mainframe database. This means that the Windows transactions can save the data in mainframe database, and they will be immediately available for mainframe transactions to be read, and vice versa. At the same time, what has been saved by Windows transactions will be available for mainframe batches for processing. So everything is done together in a consistent way, and the legacy and the new can coexist. In the second phase, you start to move batches from mainframe environment to the open world. And this works pretty much the same. So what has been, processed by Windows batch will be immediately available for next batch in the mainframe database for processing. Finally, you migrate your database from mainframe to Windows, and all your system is replatformed and available in the new platform. Why are we following this coexistence pattern? First of all, it allows us to convert Big Bang into a phase launch of business functionality. So we can have early production verification, which is very important and prevents you from enabling everything on one day and keeping fingers crossed that everything will work well. Second is that you have a fallback option. So if some transaction does not work in the new, you simply switch it back to mainframe, you fix it, you test it, and you switch it again to the open world. And then you see if things work well. And the last thing, you can optimize the CPU usage. Once you move transactions away from mainframe, your CPU usage will fall down. Since coexistence is very important, I would like to deep dive on it and introduce a switch concept to you. So before we launched the project, our CICS transactions were exposed to external world as it is shown on the picture. So we had a communication server that was processing web services, and once it was the time to call CICS transaction, the Microsoft Host Integration Server was called. Then the Microsoft Host Integration Server called CICS transaction, which utilized the data from DB2. I would say a pretty standard pattern for the mainframe world to expose CICS transactions through web services. During the project, we introduced a switch. So a switch is a part of the software in communication server that decides whether we should follow the previous path or whether we should enter the new. The new means that we go to application server, we process all the logic, all the COBOL logic in the same way as we did in CICS, and then we retrieve the data from the same database through distributed data facility. In this way, with the switch, both paths coexist and are available for usage. Switch is truly a powerful tool. It's not, I would say, very complex, but truly enables you to test the new path in a very secure way. So first, you can specify that the transactions will be executed in the new only for selected clients or selected accounts, some kind of friends and family mode. This allows you to test, to verify on production the new transactions by your employees or by appointed external testers, and there is absolutely no risk that anything will be made public if in case of failure. Once you see that friends and family mode works well, you can start switching selected transaction by the transaction ID to the new path. You can do it for selected time frame so that you execute the new only in the time when your employees are at work, so that you can have the team for troubleshooting if needed. You can limit the traffic to selected channels, to selected client segments or product type, so that, for instance, corporate customers and the whole business customers do not experience any problems if they occur. You can also limit by transaction amount. And finally, what is very important is that you can set the redirected percentage. So at the beginning, it can be like 5 or 10%, and you can gradually get to 100% so that you set all the traffic for the new path when you see that it's working well. Another important assumption is one line of code. So our project assumes that we maintain only one line of code for both platforms. One line of code is compiled both for mainframe and for .NET environment. This approach allows us to deliver business changes and to release them in parallel to a platforming project. In 2020, we delivered over 20,000 man-days of business functionality, and in 2021, it was like over 15,000. So altogether, almost 40,000 man-days of business functionality in 2 years. Imagine if you had a project where you implemented a new system, then these 40,000 man-days would be actually lost, and you cannot really afford it. Under replatforming, every single man-day that you invested in your code will be available in Windows, in something new, which is opposite to the situation when you implement a new system. Also, one line of code prevents additional cost that is related to maintenance of two separate lines of code. You don't have any double coding, you don't have any double testing, double fixing, and so on. And last, one line of code allows us to do comparison testing. So this is a very effective way of spotting every differences between the platforms. With same inputs, you are comparing the outputs on on .NET platform, and you are comparing it with mainframe platform. And if you see any difference, that means that something should be investigated. So where we are as of now, and what is the scope of the project? So the project scope is consists of 4 streams. So this is online over 2,000 transactions, batch over 4,000 JCLs, database migration, and development architecture. In case of online, the replatforming is finished. Last group of transactions are to be activated in production environment. it is working well, the architecture is stable and is ready to process peaks of transactions. When it comes to batch, the batch replatforming is in progress. Partially, it's already on production. And these batches that are on production do not influence the time of end-of-day processing, which is maintained as it was before. The data, when it comes to database migration, we have initial data conversion engine, it's delivered, and we have created several environments with new database, and we tested online transactions, and majority of online transactions work successfully, and they were tested on target database, of course, in testing environment. Last but not least, development architecture. So first we had to create a mechanism which allowed us to synchronize the code from mainframe to Git. And then based on Git, we were able to compile, build, release, and deploy the application to the Windows environment. Now we are working on reverting it. So we want the code master to be stored in Git and then synchronized backwards to mainframe so that it can be compiled and deployed over there. So to sum it up, replatforming enables smooth transition by the following. Repeatable process, so you have automated conversion, interpretation, compilation, which is secured by Raincode compiler. You are harvesting the experience from all other installations and projects, which is embedded within the Raincode compiler, and this is done automatically. The coexistence assures the smooth transition by the fact that one big decision is split into many smaller ones. So instead of having a big bang, you have multiple decisions that are far easier to be made. Comparison testing. So again, this is spotting platform differences at low costs. And automated testing. So this is repeatable testing that is also performed with a low cost. Online switch, so this is what we talked about. You are able to fall back in case of any production issues so that you can fix it and bring back to the new world. And it's not, I would say, visible as in case of a big bang. Same thing about batch switch. And of course, database migration fallback in case of any production issues. So thank you very much. I could talk for another hour or two since I'm a fan of this project, but the time is limited. But if you want to hear more about replatforming, if you are considering how to migrate your software from mainframe to the open world, I would be very happy to meet with you and spend some more time.